Hi. So now let us see next concept in this serialization. So that is the conflict serializable schedules actually. So when you can say non-serializable schedule is going to become conflict serializable, and that is equal to which serial schedule. So all these things we can learn from this concept actually, as we discussed earlier. When you have many possibilities are there for the non-serial schedules, which non-serial schedule is valid and which is not valid, which is equal to serial schedule, all these things we can find out actually. So here if you see conflict serializable schedule, so its definition is a schedule is called conflict serializability if after swapping non-conflicting operations it can transform into a serial schedule. So that is what actually swapping non-conflicting. So here the very important thing we need to understand is what is non-conflicting operations. So let us try to understand. So the definition wise, when you have a two transactions like this, xi of a and yj of b, to say that these are the conflict operations. These are the two operations. We will see meaning of each letter here. Then we will understand very easily. So here if you see, first one is A equal to B. See here if you observe, we have xi of A and we have yj of B. Then these are the data items actually. Both must be same. That means in a table, okay, you have a data like this. For example, you have a set of rows and columns. So you are talking about this particular field, for example. That means under one column, this value you are talking, that is what A equal to B. So both the transactions must work on same data item. That is what A equal to B meaning. Okay. Then next one is I not equal to J. And here I and J representing that transaction number. So though I not equal to J meaning is both should not belong to the same transaction. So we have a transaction 1 and we have a transaction 2. So operations should not belongs to same transaction actually. That is what here T1, here also T1. But here one operation, here one operation, then that is what one I is 1, J is 2. So not equal, 1 is not equal to 2, correct. Okay, that is what we will understand with the example. Then the next one is either X or Y must be a right operation. So at least one of these X and Y must be right operation. That is what we can say. Either X or Y must be a right operation. Then we can say these two are going to conflict each other. Okay. Then non-conflicting, you can swap actually. So all these things, let us try to understand with a simple example. Okay. So that is what you can see here. We took a one schedule here. In that schedule, you are going to have a two transactions. That is what T1 and T2. So that is transaction 1 and transaction 2. Here, if you observe, this is what we are talking. For example, if I take these two, okay, these two are conflict each other or not. So whatever points we discussed in the last slide, let us try to recap. The first one is what? Here the data item is A, here data item is A. So that is what both the data items are same. So that is fine. And the second one is what? Second one is this is in the transaction 1 and this is in the transaction 2. So second one is also fine. But the third one is, you can see any one of them, at least one of them must be right operation. But both of them is read operations. So third one is not satisfying. So These two, especially this operation and this operation are not conflicting each other. So you can swap them actually, non-conflicting operations. Okay. So what does it mean is reading here and here it is same, but you need to consider other things also. Now this I compare with this. If I take these two combination, write A in T1 and read A in T2 transaction, then you can see first one is, yes, both of them is same data item, that is A. So if I take another color, so both of them is A only, here A and here also A. And the second one is what actually? Both of them is from different transactions. Yes, correct. Both of them is from different transactions. And the next one is at least one of them is a write operation. So T1, it is a write operation. So these two are conflicting operations actually. Okay. So that is what swapping these two is not possible. So you cannot swap even here also. Okay, anyhow, if you observe, this is actually a serial schedule. After all T1 transaction operations completed, then you are going to start T2 transactions. Is it or not? So this is T1. After that, T2 you are starting. So, and this is a serial schedule. That is very important. This is a serial schedule. So with the serial schedules, we are not going to have any issue always. Now, let us try to take non-serial schedule. That means you can see one operation from T1, one operation from T2. Then such a manner you are doing. So that is what non-serial. Okay, both of them you are doing one after the other. Now, in this case, let us try to identify these three things. For example, if I take these two, similar, same thing, this is going to repeat actually. 1, 2, and 3 if I take three conditions. So both of them same data item and both of them belongs to different transactions, but there is no read or write operation. So both of them are the read operations. So leave them. But here if you observe, these two if you observe what it is saying, these two if you observe, first of all, same data item, correct? Same data item and different transactions, correct? And one of them is write operation, correct? What this one is saying is, with this, if I take this as a 1, so what 1 is saying is, first T2 and then T1. Okay, let it. Now, see these two you can take it, right? These two also you can take it. Second one I'm going to take. So we are proving that whether it is a this serial schedule, this schedule S2 is a conflict serializable or not. We are going to prove. So second one, if you take, what is this second? This one, this one. That means write A from T1, write A from T2. These two. Now both of them having same data item. So first operation is fine. Then second one is both of them belongs to different transactions. Then at least one of them is write operation. So both is write operation. So not a problem, right? So this is what you can write. Now from this, what you can write down, T1 is first and then T2 actually. So when all three are satisfying, what you need to write down, this is first and then this is you are doing next. But this should not be like this actually. First T2 and then T1. And this is saying first T1 and then T2. So here you have a conflict. So that means S2 not conflict serializable. You can conclude that. S2 not conflict serializable. That means this is not going to equal to any serial schedule actually, the end results. Okay. So to get more better understanding, let us try to take a next example. So that is this one, you can see. Here you try to understand. Let me take these two. these two have a conflict, right? Now you can work directly. So both of them different same data item, different transactions. One of them is write operation. From this one, what you can write down? From one, what we can write down? T1 first, T1 first, and then T2. Let it be. Then next, these two you can take. Is it second one? So second one is saying what? Second one is also saying first T1 and then T2. Under all three operations, you can check. Both of them same data item, different transactions. At least one of them is write operation. So it is also saying T1 first and then T2. Is it or not? Now, next third one. See, this is what write conflict. So we took all possible combinations here. And even these two also you can take. These two also. That is what third one if you take. So third one is also first T1 operation, this one, and then T2 operation, this one. So what does it mean? What you can write down? T1 first and then T2. So everywhere on data item A, it is saying same order actually. That is what you need to observe. And also not just for data item A. How many items are there in this schedule? Data item A1 and then you have B. That means this one. So not just for one data item, for every data item, you must get the same order actually. That is what very important thing. For example, here also, these two are going to conflict. So that means fourth one, let us take this as a fourth one. Okay. So fourth one is saying what? First T1 and then T2. Is it or not? Then fifth one. So next these two are conflicting. So let us take this as a 5. So even this one also T1 first and then T2. That means this is happening first, T1, and then this one, T2 is happening. And next one is these two if you take that as a sixth one. Even this also saying first T1 and then T2. So that means in this case, you can see even for B also following the same order. So what you can say from this is, okay, what you can say from this is T1 first, then T2. That means this non-serial schedule S3 is equivalent to serial schedule T1 operations all first and then T2 operations. So you can run this one, you are always in a safe side. There is no problem in this schedule actually. So now S3 is conflict serializable, which is equal to S1 followed by T1 followed by T2 actually. That is what S1. So S1 is conflict serializable with S3 actually. But S1 is not conflict serializable with S2 or anyone actually. Okay. So that is what the meaning of this one. Okay. Now, further if you discuss on this, okay, to get the more details, here you see, here you can see in the definition, if you observe swapping the operations. So here you can see, if I swap these two operations, is there any problem? No, right? Reading B value at here or reading B value at here is same. So read A is coming to here. Swap those two actually, their positions. So it is came to here, it went to here actually. Now these two if you take, these two also, see here the main thing you have to observe, their data items are different. So because data items are different, even their order of reading you changed, no problem. We will see the meaning here also. Now these two if you take, here also write A, write B. Their data items are different. You can swap them. I can bring this one to here. That is what write B. and I can bring this one to here. That means write A. So now what is your observation? First all T1 transaction operations and then T2 transaction operations. What does it mean? T1 first and then T2. So that is what from S3 you make it equal to S1. That is what schedule 1, this one I am talking. First S1 operations here, is it or not? First S1 operations and then S2 operations. So that is what S1 is conflict serializable with S3 actually. For example, here if you take, can I swap here read B and then these two? Can I swap these two? Is it possible? No. Or for example, if you take these two, can I swap these two? What is the problem here if I swap? For example, A value is 5. Okay. A value, here it is 5. You are reading it as a 5. Here you are going to read as a 5. Then you are performing right actually. Now, for example, after doing some modifications, A value going to become 10. That means you are writing this A value as 10. So that's all here. But for example, if you swap those two operations, for example, if I take this one, if you have a write operation here A, and if I have a read operation A here, what's going to happen? You will read this as 5 here, no problem. And you are going to write A value as 10. So A value as 10. That means you are written 10. Now when you are performing read operation on A, what you are going to read? The value written by T1, that is 10, you are going to read. So that is what problem. So by swapping the two operations from the different transactions, value should not change actually. That is what you can ensure in this swapping. Is it clear? So this is what actually S1 is. So that is what summary you can see. Sequence of conflict operations in S1 and S3 are the same because they are conflict equivalent. But S1 is serial schedule, S3 is non-serial schedule. So always recommended is non-serial schedule so that you can fulfill all the transactions. Is it? So that is what we have to find out non-serial schedules actually. Okay. So proper non-serial schedules, valid non-serial schedules. Then what is the another statement? The sequence of conflict operations in S1 and S3 are not same actually, are not same because they are not conflict equivalent. So this statement is wrong. S1, this is S2 actually, not S. Okay. The sequence of complete of S1 and S2 are not same because they are not conflict equivalent. But S1 is serial schedule. Of course, S2 is non-serial. So this is not a proper one. That means S2 is not equivalent to any serial schedule actually. Okay. So this is the example. From this example, you can understand that what is the conflict serializable, okay, and to which serial schedule it is going to become equal if it is valid, okay. Then let us see the further some more examples so that we will get the more clarity.